Welcome to section 3.4, which is on division and exponents. So most of this lesson is going to be on division. So what does division mean? How do we draw pictures? How do we use base 10 blocks? Just different types of methods for dividing. So let's just start by talking about the two different ways that you could think about what division means. So we call these sharing versus measurement concepts. So consider these two problems. And both of these problems really are the same problem. In both of these we're doing 20 and we're going to divide it by 4 and get 5. So part A, class of 20 children is to be divided into 4 teams with the same number of children on each team. How many children are there on each team? So we're given a total here and we're given the groups. So we're given the number of groups and we're being asked how many in each group. So we're asked how many in each group. Okay, this next problem, we've got a class of 20 children, so we've got the same total. We're going to be divided into teams of 4 children each. So this time we know the number of kids in each group. We didn't know that before in the last part. And then now we're being asked how many teams or how many groups there are. So different ways of looking at the same question. So the first one relates to part A. So sharing division is when you have sort of a total. So let's say we've got 20 kids. And if we want to model 20 divided by 4, the way that we use sharing division is we interpret this second number. We say this is the number of groups. Okay, so let's just draw a picture. So 20 divided by 4. If you know that you need 4 groups, then you're going to draw the groups first. So for sharing division, you're going to draw 4 groups. So you could do that by just drawing 4 boxes or 4 circles. And then figure out how many go in each. Okay, so I could take my 20 and imagine like you've got 20 people and you just kind of say, okay, person 1, you're going to go here. So we're going to go, we've got 1, 2, 3, 4. Okay, now we still have more people. 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So if I divvy up my 20 people into the 4 groups, I end up getting 5 in each, and 5 is my answer. Okay. The other way to look at it, measurement division, I also consider this like a subtractive method. Okay, so when you see measurement division, think subtraction. This relates to part B up here. So if you have 20 kids, so again, we're doing 20 divided by 4, same problem. If you're dividing by 4, now what you're going to do is you're going to keep subtracting 4. So keep making groups of 4 until you can't go anymore, and then you're going to figure out how many groups you can make. So if you have 20 kids, you're going to say, okay, well, I'm going to make a group of 4 kids. There's one group. I'm going to make another group of 4 kids. There's another one. So 1, 2, 3, 4, 5, 6, 7, 8. So now we got 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, and then I'm out of kids. So in this case, there's 5 groups. And so that represents an answer of 5. So you can think of 20 divided by 4 in either way. You just have to, I think it depends on the type of problem, and we'll talk about that a little bit later. And it also just depends on what makes more sense to the person doing it. So let's go over some definitions, some terminology in terms of division. So we've got some terms here. Let me list out or write an example problem, and we'll talk about these terms in relationship to the problem. So let's do 58 divided by 7. So how do we do this if we use long division? So we say, how many times does 7 go into 58? It goes in 8 times. 8 times 7 is 56. we subtract, and we get 2 left over. So we have our 2 is our remainder, so that's one of the terms. The 7, that's the divisor. It's the number that's dividing into the 58. The 8, that's your quotient, and the quotient, that's the same thing as the answer. And then the 58 is the dividend. Well, all of these numbers have a special relationship. If you think about, we just divided 58 divided by 7 and we got 8, remainder 2. So that was the answer, okay? So let's just write that down. So we said 58 divided by 7 is equal to 8, remainder 2. We can actually rewrite that using multiplication, and it's helpful because when you're doing division, a lot of times multiplication tends to be easier, so we can use multiplication to check our work. So now what we can do is we can go backwards. You can take the divisor and the quotient, these two numbers, multiply them, and then add in this remainder, and you should get the answer, which is the dividend. So let's try it. So we're going to check here, and we're going to say 7 times 8, which is 56, plus the remainder, which is 2, that's 58, so that ends up working. So that's what this says right here, this division algorithm theorem. And you know, I listed out the variables, that's how the book writes it, but more simply what you can do, instead of writing A, you can just say the dividend is equal to the divisor times the quotient plus, I'm running out of room here, but plus the remainder. And that's a great way to check a long division problem. The other property that I want to talk about related to division is the division property of 0. So what happens when we divide by 0, and what happens when 0 is being divided by? So one thing you can do is just use your calculator. So take your calculator and do 0 divided by 5, and then do 5 divided by 0. And see what happens. When you do 0 divided by 5, you end up getting 0. Your calculator gives you an answer, not a problem. When you do 5 divided by 0, you end up getting some sort of error message. That means that this, we call it undefined, which means you can't do it. So it's impossible to divide by 0, but it is possible to divide 0 by any number, and that will always be 0. So let's talk about why that is. So if we talk about 5 divided by 0 and what that means in terms of groups, you could think of this as saying, okay, well, there's 5 kids, like in the problem above. Let's make 0 groups. If we make 0 groups, how many are in each group? Well, if we don't have any groups, like that doesn't even make sense to make 0 groups. The other way to think of it is, okay, I have 5 kids. Let's start putting 0 people in each group. Like the whole concept doesn't make, it just doesn't make any sense. One way that you can, just a little trick to help you remember that the answers to these division problems is I always remember okay and no, and I write these as a fraction. So it's okay to have 0 on the top. So for example, it's totally okay to do 0 divided by 5. That works. It's not okay or no to have 0 on the bottom. So if you do 5 divided by 0, that's not okay. So it doesn't work. All right, so now that we've talked about the properties, let's look at a couple models for division. So, well, and actually we'll just do one. When we talked about multiplication, so we talked about how multiplication is just repeated addition. So for example, 4 times 5 is the same thing as 4 plus 4 plus 4 plus 4 plus 4, okay? Or 5 times 5 times 5 times 5. You could write it either way. But you could just do repeated addition. Well, repeated subtraction can be done to do division. So if you have to do 15 divided by 2, for instance, you start with 15. Now with division, it doesn't work the same as multiplication in a sense that you can do it any order. You can't start with 2. You have to start with the first number. So if you take 15 and you keep subtracting 2, this is kind of like you keep putting 2 people in a group. Okay, you get 13. Subtract 2, subtract 2, subtract 2, subtract 2, So you keep subtracting 2 until you can't subtract 2 anymore. Now in this case, we get a 1, so that represents a remainder. But if we look at, I'm going to circle with a different color, let's look at every time we subtract a 2. We subtracted a 2 1, 2, 3, 4, 5, 6, 7 times, so the answer is 7 remainder 1. Now, if you want to do one, I'll show you a simpler one where it doesn't have a remainder. So an example might be like 8 divided by 2. You could just say, okay, well, 8 minus 2, minus 2, minus 2, minus 2. In this case, you end up with 0, so that just means no remainder. But you still go through and you circle and you ask, well, how many times were you able to take off 2? I was able to take off 2 4 times, so the answer is 4. So if anybody is struggling with division, just go back to the idea that you're just subtracting over and over and over again. And just to, back this up a little bit with this example above, the subtractive property, that's what we did up here with measurement division. We started with 20 and we took off 4 and then another 4 and then another 4 and then another 4 and then another 4 until we didn't have any left. And we said 5 groups, but we could also say we subtracted 5 times. Same concept. Okay, so we can't talk about division without talking about the standard algorithm, the long division algorithm. So I do want to do a couple of these because for a lot of people, it may have been a long time since you've done long division. So this would be a great time to maybe, if you're really rusty, watch the first one and then try the other ones. But if you think you might want to try these, remember some of this, then pause the video and try these first, and then you can watch me go through it. So when you're dividing, the first number is always the number that goes inside the box. So 96 divided by 8. Remember, 8 is the divisor, 96 is the dividend. So the dividend is always first, and the divisor is always second when it's written horizontally. Next, you say to yourself, okay, does 8 go into 9? It does. 8 goes into 9 one time. 1 times 8 is 8. And then you're going to subtract. 9 minus 8 is 1. And then you carry down the next number. 8 goes into 16 twice. 2 times 8 is 16. You subtract, you end up getting 0. So in this case, we're done. So you get an answer of 12, remainder 0. Now let's use the division algorithm to check our work. So that means we're going to take this number times this number and add in the remainder. So 8 times 12 is 96 plus 0 is 96, and that ends up giving us the number that's inside the box, which is what we want. So that works. Okay, next problem. So 44 divided by 13. Now in this case, 13 cannot go into 4. So if it can't go into 4, you use the next number with it. So 13 goes into 44. How many times? At this point, you could start adding 13 to figure out how many times it goes into 44, or you could also use multiplication. So it just depends how comfortable you are with multiplication versus addition. So if I add up 13 1, 2, 3 times, or 13 times 3, I could have done that also, you get 39. If I do it again, I get 52, which is too much. So I'm going to say 13 goes into 44 3 times, and that's 39. And then I'm going to subtract. So I have to borrow. So 14 minus 9 is 5 there. And then you carry down the next number if you have it, but this case I don't have a number. So my answer is 3 remainder 5. And then let's use our division algorithm to check. So we're going to do 13 times 3 plus 5. So 13 times 3 is 39 plus 5 is 44. And that works out because that's the number that was inside the box or the dividend. So let's try the last one. So 546 divided by 31. So 31 can't go into 5, but it can go into 54. So at this point on the side, we can add up 31. If we add it up twice, we get 62, which is too much. So I'm going to say 31 goes into 54 one time. And then you subtract. 4 minus 1 is 3, 5 minus 3 is 2, and then you carry down the next number, 236. Now at this point we have to figure out how many times does 31 go into 236. It's a big number, so if we were adding it would take a while. Totally fine if that's how you want to do it. I'm going to just use multiplication though. So I'm just going to guess here, and I'm just going to say let's just start by doing 31 times 5. I'm just going to guess. 3 times 5 is 15. I'm left with 155, too little. Let's do 6. 3 times 6 is 18. Let's do 7. 7 and 1 is 7. 3 times 7 is 21. Okay, we're getting close. So we got 217. Now if I add another 31 to that, it's going to be too much. So watch what happens. So 31 times 8, and then we get 248. That's too much. So I want to do 31 times 7. So 31 goes into 236 7 times, and I get 217. And then I'm going to subtract those two numbers. So I'm going to borrow, and I get 16 minus 7, which is 9. 2 minus 1 is 1, and then 2 minus 2 is 0. So 19 is my remainder. I don't have any other numbers to bring down. So my answer is 17, remainder 19. And then let's check our work using the division algorithm. So we're going to do 31, this number times this number plus that number. So times 17 plus 19. If you work that out, you end up getting, it's 200 and I think that's 200. Yep, that'd be 217 plus 19. Oh, wait. Nope. Sorry about that. That's going to end up, if you multiply those together and add 19, then you end up getting the 546, which is the number inside the box. So that ends up checking out, and we know we got the right answer. So keep in mind, I know we only did 3, but if you're really rusty with long division, you're going to need a lot more practice than this 3. So you're going to get some practice on your homework, but also keep in mind there's a lot of resources online, and you can also email me for more resources too, and I can give you some more practice problems if you need them. So we're going to talk about how to use base blocks, just like we did with adding, subtracting, multiplying. So I love using base blocks for division. I really think it helps students understand what division means. There's 2 different methods we're going to use, and they line up with the methods that we talked about on the first page. So the measurement concept and then the sharing concept. So let's start by drawing 488 using blocks. So we're going to do, remember, a flat is 100. So 100, 200, 300, 400, 480, 1, 2, 3, 4, 5, 6, 7, 8 longs, and then 1, 2, 3, 4, 5, 6, 7, 8. So our options here to divide by 122 are to either make 122 groups and figure out how much goes in each. That would take forever. Or we could subtract 122 until we can't do it anymore. That is the subtractive or the measurement concept, and that's why I asked you to use that method here, because 122 groups would just be not the right move for this one. It would take forever. So let's keep subtracting 122, and I'm going to do it using the blocks. So if you had these in front of you, like the actual blocks, you just take away 122 at a time. So there's 122. So I subtracted 1 time. I'm going to just tally over here. And then there's 122. Okay, did it again. 122. I did it again. And then 122, and I did it again. So I end up doing it 4 times. So 488 divided by 122 is equal to 4. Okay. Now with these pictures, usually we don't use these pictures when we're dealing with remainders. I mean, you can, but you really just start with these simpler problems. By the time you get to crazier division problems with big remainders, you're going to be not using blocks to do those problems. Okay, this next one, you're going to start the same way. You're going to draw 522. So 500, 5 flats, 22. And with this one, we don't want to keep subtracting 3 because that would take forever if we're starting at 522. So with this one, I'm going to make 3 groups. So I'm going to use a different color. So I'm going to make, here's a group, here's a group, and here's a group. And I'm going to try to divvy those up amongst those 3 groups. So this is what I'm going to do. I'm going to start with the flats, and I'm going to say, okay, this flat I'm going to put right here. This flat is going to go here. This flat is going to go here, okay? Now I have 2 flats left, so I can't share those evenly. So what do we do? It's kind of like you have 2 cookies, but you have 5 children. What do? Well, you start breaking up the cookies. You split them up into pieces so that way everybody can get the same number of pieces since they can't all get a whole cookie. So we're going to do the same thing here. So this flat here, this is worth, remember, it's worth 100. So I'm going to exchange that for 10 longs. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, that's going to go away. I'm going to do the same with this one since I cannot split one flat up amongst the 3 groups evenly. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I'm just making exchanges. Now I'm going to go ahead and I'm going to divvy these up. So I'm going to put a long in there, and then a long, and then a long, and then another long, and then another long, and then another long, and then another long, another long. Oh, you know what? I think I miscounted right there. Yes, I did. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 2, 3, 4, 5, 6. And then I should have, I forgot to cross that one off. So I should have, oh no, that actually works. 3 left. Yep. So 1, 2, 3 left. 1, 2, 3. Okay, so if I did that right, we should, oh, you know what? Nope, I should have one left over. Hold on one second. 1, 2, 3, 4, 5, 6, 7. Okay, yeah, this one I forgot to cross off here. We had one long left over that wasn't, because we should have 7, 7, and 7. That's 21, and we had 22 longs. So there was one long that did not get used up. So that was left over. So what we're going to do with that is we're going to exchange that into 10 units. So now we have these 10 units and we have these 2 units over there, and if we have 12 units in 3 groups, then each one should get 4. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and that takes care of the rest of these. Okay, so you can see it's a little tedious. It's really easy to like make mistakes, but I mean it's simple in nature, and I think if you do this with actual blocks it's even better. So what's our answer? Well, how many are in each group? So we have 100. We've got a flat 1, 2, 3, 4, 5, 6, 7 long, so 70, and then 4, so 174, which is what you get when you take 522 and divide it by 3. So this next part, rectangular way, oh, I didn't spell that right, did I? That should be an N there. This part relates to multiplication. So if you remember with multiplication, we did an example like 4 times 7, and we drew a rectangle, and we said, okay, we could draw a rectangle that was 4 by 7. And if you count the blocks in between, there's 28 total cubes inside of that rectangle. So we're going to kind of go backwards with division. So if you have to do 336 divided by 12, so 336 divided by 12, and we can just, you could put that in your calculator, find the answer if you'd like. It's 28. What we can do is we can take 336 with base blocks, and if we were in class, what I would do is I would have everybody map or get 336 using base 10 blocks. So you get 3 flats, 300, 30, 1, 2, 3, 4, 5, 6. And then remember these units, they're actually little cubes. Okay. And then these are little like sticks. Okay. And then what I would ask you to do is I would ask you to take those blocks and I would ask you to try to make a rectangle using those blocks. And the rectangle would look something like this. So you get a rectangle and one dimension would be 12 and the other would be 28 because 12 times 28 is 336. And the way that you would do that is you would actually, you're going to have to just use your imagination for a minute, is you would take, what would happen is we'd take two flats, okay, so remember this is 100 and 100 each, okay, and then we're going to take 8 longs, so 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7, 8, okay, so 8 longs, remember 8 times 10, this would be 80, okay, so the length of this rectangle, if this flat is 10 by 10, this would be 10, this would be 10, and this would be 8. So altogether, this is 28, the length of this rectangle, which is the same as what we have up here. And then in this direction, to get 12, this would be 10. You'd actually put 2 longs like this. So this would be 2, so that it's 12 altogether in this direction. And what happens is if you fill it in, okay, and notice up here in this picture, so we've got, here's a flat and here's a flat, and if you're wondering, well, where does this third flat go? It actually doesn't even fit nicely, so what you can do is we'd exchange it for 10 longs. And 8 of them are here. 2 of them are here. We've got an extra 2 here, so that's where those would go. And then all of the extra units, okay, we've got units that would fill up this spot. So we'd go 1, 2, 3, 4, 5, and we've got a bunch of units in there. And then all together, we end up getting 336. So we've got 100, 180. This is 20. This is 20. So if we add that up, we've got 100, 200, 300, 320. And then we need an additional 16, and that's where you're going to see all of these units in this section are 16, and then you get 336. So I know it's hard to see in this video because you don't have the actual blocks ahead of you, in front of you, but I just wanted to point out that you can take your base 10 blocks and actually make a rectangular array, just like we did for multiplication, to show division as well. So we talked about properties in multiplication. I just want to mention with division, and we talked about those properties in terms of division actually in the last section, but does whole number division satisfy the closure property? So do you remember the closure property says that in order for a property, or in order for a number system to be closed, it means that when you do an operation that the answer needs to be the same type of number as the numbers that were used in the operation. So for example, if you have a whole number divided by a whole number, do you always get a whole number? So for example, 10 divided by 5 is 2. So whole number, whole number, whole number, it works. What about the other way around? 5 divided by 10. That's 1/2. Is 1/2 a whole number? It is not. So we say no, the division does not satisfy the closure property. Okay, so let's finish up with division by talking about some mental math and approximation, and then we're going to get into exponents. So this first part with mental calculation says use equal quotient. So what does that mean? I'm going to actually write this like a fraction, so 120 divided by 20. Equal quotients just means that if you want to divide both of these numbers, and it's the same as when you reduce fractions. If you want to divide them by the same number, that's why it says equal. It's okay, and I'll show you why it's okay in a minute. So if you do 120 divided by, let's say 2, or actually, you know what, we could even do 10 here. And 20 divided by 10. When you divide each number by the same number, you end up getting the same proportion, so you can get the same answer. So 120 divided by 10 is just 12, and 20 divided by 10 is just 2. You can just lop off those zeros like that. That's an easy trick to do also. And 12 divided by 2 is 6. So same thing here. So if we do 180 divided by 12, that might not be a calculation you can do in your head, but maybe you see 18 and you think, I know 18 is divisible by 6, and I know 12 is divisible by 6. So 18 divided by 6 is 3 plus that 0. 12 divided by 6 is 2, and then 30 divided by 2, that's 15. So that's doable. And, you know, there are some people that can just do 180 divided by 12, or maybe dividing by 6 that wasn't good enough, like you still had trouble, but it's just a nice option to have. And then the next part, this has to do with, we're going to talk about approximation. So this is rounding. This is where we're just going to mentally approximate. So by rounding one or both numbers, and looking for compatible numbers. So what could we make this number and this number so that we would actually be able to tell the answer? One thought here, I'm thinking two things actually. You could do 400 divided by 40. So that's one option. And if you write it like this, it's even simpler because you can cross off those zeros, and then 40 divided by 4 is 10. The other option would be maybe to make that into 500 divided by 50. Okay, so 500 divided by 50, that also is equal to 10. So either one of those would be a reasonable option. And if you're thinking of something else, it could be a possible answer too. These are not the only possibilities here. So for this next part, we could round 145, I don't know, maybe 150, and then think about what we could round this to. Now, my first instinct is 20, but then I think, okay, 20 doesn't go evenly into 150, but 25 does, okay? So think how many quarters go into $1.50. So we say 6. So the answer is approximately 6. So in this section, we used our own judgment of how to round. So there's not one right answer. In the second part, front end, we're asked to use front end estimation. So that means keep the leading digit and make the rest zeros. Okay, so this is a rule now that we're actually following. This has one right answer. So for this, we're going to do 800, keeping that 8 and keeping the 2, divided by 200. And if you need to write it this way, it's nice because you can cross off those zeros, and then you're left with 8 divided by 2, which is 4. And then for this one, we'll do 7,000 divided by 2,000, or again, if you want to write it vertically, so you can cross off all those zeros, 7 divided by 2 is 3.5. So approximately 3.5 for that one. Okay, so we're going to stop with division, and we're going to jump into, we're going to jump into exponents. So discussion. You are teaching a unit on exponents, and a student asks you what 4 to the 0 power means. One student volunteers that it is 0 since exponents are a shortcut for multiplication. How do you respond in a meaningful way? So think about this. So I guess first is a question, is 4 to the 0 power, is that 0? Okay, the answer is no. 4 to the 0 power is 1. Okay, the next question, so the student said exponents are a shortcut for multiplication. Are they? So for example, 4 to the 3rd power is 4 times 4 times 4. So is this right here a shortcut for multiplication? I would say yes. So I would say they're absolutely correct. That's how I would respond. I would say, you're absolutely correct that exponents are a shortcut for multiplication. But 4 to the 0 power isn't 1 because the power, it's not telling you to multiply by that number. So 4 to the 3rd power is not 4 times 3. 4 to the 0 power is not 4 times 0. So it is a shortcut for multiplication, but it doesn't mean to just multiply the base and the exponent together. So let's talk now about why 4 to the 0 power is equal to 1. And actually, if we scroll down here, I've got a little box where it says 0 is an exponent. Any number to the 0 power is equal to 1 always. And this is a question or a concept that I've always gotten a lot of questions about, like why? It just seems so weird that it would be 1 and not 0. I think the best explanation that I can come up with that I think is reasonable for kids is just to use a pattern. So take for instance 2 to the 4th power. Let's write that out. 2 times 2 times 2 times 2, you end up getting 8. 2 to the 3rd power. 2 times 2 times 2, times 2, I said 3, so I wrote it down. 2 times 2 is 4, I wrote the wrong answer down. 2 times 2 is 4, times 2 is 8, times 2 is 16, sorry about that. 2 times 2 is 4, times 2 is 8. I'm only a math teacher, but I can't multiply. 2 times 2 is 2 to the second power is 2 times 2, which is 4. Now let's look at the pattern here. How do you go from 16 to 8 and from 8 to 4? 16 to 8, we're cutting it in half. We're cutting it in half. 2 to the first power is just 2. How do you go from 4 to 2? Well, you're dividing that by half. So you're not dividing it by half, you're dividing it in half. So let's keep going. 2 to the 0 here. If we were to divide 2, so what's 2 divided by 2? We would end up getting 1. So if we keep with the pattern there, we end up getting 1. And then if you're familiar with negative exponents, those are really weird. 2 to the negative 1 is just 1/2. And the nice thing about this is the pattern continues. So 1 divided by 2 is 1/2. 2 to the negative 2 power, you divide 1/2 in half, and then that equals 1/4, and the pattern just continues. The other way that you can explain to students is really with multiplication, you kind of have an invisible 1 in front of all of this. So 1 times all of this is just 16. 1 times all of this is just 8. There's this invisible 1 there. And every single time you go down a row, you're removing a 2. Well, when you remove this 2, you end up with just this 1. So that's another way to explain it. I like the dividing by 2 way better, but either one is a good option. So let's just remember here, any number to the 0 power is 1. And it could be a crazy, it could be variables, anything, any number. This could be actually number expression, anything. So you could have like 3x to the 4th, y to the 7th, z to the negative 25th power, all over negative 500, x to the 4th, y squared, all of this to the 0, and it would just be 1. Okay, so it does not matter what's on the inside as long as if it's all raised to the 0 power, your answer is 1. Okay, so next part, let's talk about some properties, and I'm sure this is going to be hopefully a review or familiar for most of you, but it's good to kind of go back and just kind of jot this stuff down. So this first one, I'm not even going to bother with the exponent. Basically what this says is we're just going to write out what it means for a base to have an exponent. So for example, 5 to the 4th power means 5 times 5 times 5 times 5. And you can write it with the variable like a to the nth power means a times a times a times a, how many times n is. Okay, that's how the book would write it. I think it's just simpler to just use an example with numbers. So this one down here, let's do the same thing. So if you have the same base, different exponents. So for example, well, here, I'll write that out. I'll write out what this is. So same base, different exponents. You're going to take the base and you're going to add those exponents. So for example, let's take 5 squared times 5 cubed. Same base, different exponents equals 5 to the 2 plus 3 power, or 5 to the 5th power. Now keep in mind, you can always do this longhand. You do not need to memorize these rules because 5 squared, think about this, is 5 times 5. 5 cubed is 5 times 5 times 5. How many do I have all together? Well, I have 5. So you could write it out. All right, next one. Different bases, but same exponent. So you can multiply those bases and bring them to that exponent. So for example, let's say you had 4 to the 3rd power times 5 to the 3rd power. You would do 4 times 5 and raise it to the 3rd power, or 20 to the 3rd power. Again, you could also write this out. So 4 to the 3rd is 4 times 4 times 4. And 5 to the 3rd is 5 times 5 times 5. And then if you brought each of those 4 and 5s together, 4 and 5 is 20, then you'd have 3 20s, which is the same thing as 20 to the 3rd. So totally doable to write out. Okay, so the next one, when you have a number to an exponent and then a number on the outside of the parentheses, you're going to multiply those together. So for example, if you had 6 to the 3rd power raised to the 5th power, that would be 6 to the 15th power. And to write this out, this would be 6 to the 3rd power is 6 times 6 times 6. And if that was to the 5th power, that means 6, 6 times 6, 6 times 6 times 6. Write this out 5 times. Okay, I'm running out of room, but you get the idea. And how many 6s do you have altogether? You end up getting 15. So it's time consuming to write it out, but it definitely helps make sense of the problem. So no worries if you need to. And then last but not least, we're going to do the division. So if you have the same base, so let's do 5 to the 7th power divided by 5 to the 4th power. You're going to subtract those two numbers. Oh, and you know what? Let me do, that example was good, but I'm going to write this down first. It's going to be m to the n. So for example, I'll write it down here. 5 to the 7th power divided by 5 to the 4th power. You're going to subtract 7 minus 4, and it's going to be 5 to the 3rd. It's easier to see when they're written vertically. So for example, if you, this is the same thing, m minus n, but if I were to write it 5 to the 7th over 5 to the 4th, just subtract those exponents. And this is why the nice thing about writing them vertically is you can easily write this out. So 5 to the 7th is 5 times 5 times 5, 5, 6, 7, so 7 of those, and then 4 on the bottom, and then you can just cross them out and you can see that there are 3 left over, or 5 to the 3rd. So it makes it really simple when you write it that way. So some examples. This would be a great time. Pause the video, work on all these examples, and then you can check your work when you're done. So this first row, so we've got 2 multiplied by itself 5 times, so 2 to the 5th. We've got 3 squared times 4 to the 4th. It looks like there's 8 squared, 7 cubed, 6 squared. If you want, you can put multiplication signs between them, or you can just write them next to each other. And then it looks like we've got an x squared, a y, and a z cubed. Okay, for this next one, we can bring these 2's together, and then 8 plus 4 is 12. 4 to the 8th power. We can bring these together by 2 to the 8th power times 3 to the 7th, and then add 4, 2, and 3, so that's 9, and that's because they all have the same base, x to the 9th power. Okay, so example 3, so it looks like the same exponent in this case, so we can bring the bases together. 5 times 7 is 35 to the 2nd power, and it looks like for this one, x, y, z, we can just write it like that. 3 times 5 are 15 to the 4th power. And then with this one, we don't have the same bases and we don't have the same exponent, so this one you cannot. So you can't bring them together because there isn't a rule that would apply. Example 4, so let's try this one. We're going to multiply those exponents since there's parentheses there. So 4 to the 6th power, x to the 10th power, y to the 21st power, 7 to the 18th power. And then now we've got division. So as long as we have the same bases, we're going to subtract exponents. So it's 3 squared. 5 to the 4 minus 3 is 1, or just write 5. 6 minus 2 is 4. And then 5 minus 3 is 2. And again, for these, you can write them out. X times x times x over 2x's. You cross them off, and then you end up with 4 left over. So there's a ton more we could talk about in terms of exponent. That's just it kind of touches on it, but we're just going to leave that there, and then we're going to jump into order of operations, and this is the last part of the notes. So for order of operations, we're going to use, we call it PEMDAS, or you may have heard of the mnemonic, please excuse my dear Aunt Sally. So the P stands for parentheses, the E stands for exponents, the multiplication, division, addition, subtraction. This is the order in which you should do it, although the multiplication and division and addition and subtraction, actually occur in the same, they're the same priority, but we're going to do them from left to right. So I'm actually going to write this vertically. So instead of horizontally, I'm going to write it like this. So please excuse my dear Aunt Sally. These you're going to work left to right. And then addition and subtraction, you're going to work left to right, meaning if you have a problem where there's both multiplication and division, you're going to do whichever is the most left first. So for example, if you have 2 plus 4 divided by 2 times 6, you've got division and you've also got multiplication. You've got to do that division first, the 4 divided by 2, because that is left. It comes first. If it was the other way around, if it was 2 plus 4 times 2 divided by 6, then you would need to do the multiplication first because it's most left, it's leftmost. Okay, so what I recommend with order of operations is you do one step at a time, and I know it's tedious that way. You have to write down more, but I think it definitely helps with the thought process. It helps catch mistakes that way. So for the first one, we're going to start by looking for parentheses because those come first. So that means do the inside of parentheses. Parentheses does not mean multiplication. If there's a problem where they use parentheses to multiply, that's different. So for example, if this was 2 times 6 like this doesn't count as parentheses. This counts as multiplication. So you would actually do the division first still. So for this one, we're going to do the inside of the parentheses first. So we're going to write down 5 cubed minus 2 times 1 plus 3 is 4. So I'm going to write 4 to the second power. Now I'm going to do exponents next, and you could work left to right or do them really at the same time. 5 times 5 times 5, 125, minus 2 times 4 times 2 is 16. Now I've got subtraction and multiplication. So I'm going to do multiplication first because it comes before subtraction. So 125 minus 32, and that gives me 93. Okay. So for the next one, I've got subtraction, division, multiplication, addition. So division and multiplication are the same priority, but I'm going to do the division first because reading from left to right, that comes first. So I'm going to do 11 minus 4 divided by 2 is 2 times 5 plus 3. Then I'm going to do the multiplication next. 11 minus 10 plus 3. Now subtraction is going to come first because it occurs first, reading left to right. 11 minus 10 is 1, plus 3 is 4. I work on the inside of the parentheses, 15 minus 3 times 4. Then I do multiplication, 15 minus 12, or I'm sorry, 7 minus 2 is not 4. 7 minus 2 is 5. And then 3 times 5 is 15. 15 minus 15 is 0. Okay, exponents come first here, so 2 times 25 is 50. Now notice and this doesn't always happen, but like in this one, had I multiplied these first and got 10 squared, that would have given me a completely different answer. So it's really important that we use the order of operations there, and for most of these. So for this one, I look for parentheses first. So 3 squared times 4 minus 2 times 5 minus 3 is 2. Now I'm going to do my exponents. So I've got an exponent there and an exponent here. And you could actually do those at the same time. So 3 squared is 9. 2 cubed, 2 times 2 times 2 is 8. And now I've got multiplication and I've got multiplication. So I can just work left to right. So 9 times 4 is 36 minus 2 times 8 is 16. And that gives us 20. So for the next one, I want you to look at this division sign. We're going to do the top separately. You almost have to look at these as if there's big parentheses around the top and the bottom when you have a big rational expression like this. So we're going to work on the top and work on the bottom until we get answers for both of those, and then we'll divide those as our very last step. So on the top, we're going to work inside the parentheses first. So 6 plus 2. Here we could do these exponents at the same time. So 3 cubed, 3 times 3 times 3 is 27, minus 4 squared is 16. Okay. The bottom, we're going to work on the inside also. So 6 times, we also have 27 minus 16. So I'm going to come down and do the numerator again. So 6 plus 2. So 27 minus 16 is 11. 4 squared, we could do that now if we wanted to and just put 16 there. So 6 times 11. Okay, come over here. Actually, I'm going to come down below. 6 plus 11 squared is 121 plus 16 divided by 66. So 6 plus 2 times 121 is 242 plus 16 divided by 66. And now we can just add those across. So we get 264 divided by 66. And if you divide those two numbers, you end up getting 4. And you don't always get a nice answer, but I would say a lot of times for these you do, just because the goal is just to practice order of operations. And it does make it a little bit nicer that way. So we've got 3 more here, so bear with me, we're almost done. So the inside of parentheses, so 8 minus 1 minus 18 minus 2 is 16. And at that point, I don't even really need those parentheses. They don't do anything there. They're not telling me to do an operation inside. So I can drop them, and then I'm going to work left to right. 8 minus 1 is 7, minus 16 is negative 9. Okay, this next part, I've got, I'm going to do the inside of parentheses first. So I've got subtraction, addition, and division. I'm going to do the division first. So 4 minus 1 plus 8 divided by 8, so I'm doing this right here, is 1 times 5. Next, I'm going to do the subtraction. 4 minus 1 is 3. And then 3 plus 1 is 4. And then I multiply those and I get 20. Okay, last but not least, I. So we're going to do the numerator and denominator separately and then divide at the end. So I'm going to work on the parentheses first. So 18 plus 18 divided by 3. Same thing down here. I've got some parentheses. So 6 plus 2, 3 squared is 9, minus 2 cubed is 8 squared, plus 2 squared. So in this numerator, I'm now going to divide those because that comes before the addition. So 18 plus 6, 6 plus, I'm going to do the inside of the parentheses. And then on the top, I can combine those. So I get 24 on the top. And then down on the bottom, we're going to do the exponents. So 6 plus 2 times 1 squared is 1, plus 2 squared is 4. So 24 divided by 6 plus 2 plus 4, 24, 8 plus 4 is 12, 24 divided by 12 is 2. Awesome. So that sums up the division and exponent section. If you have any questions, as always, just let me know.